Neupane. Today I am here to tell about terrestrial magnetism. Our Earth behaves just like a huge magnet. The fact that the Earth is magnetized was first given by Dr. William Gilbert 400 years ago. The south pole of the Earth's magnet is towards the geographical north pole and the north pole is towards the geographical south pole. The study of the Earth's magnetism and its various elements is called terrestrial magnetism. Causes of the terrestrial magnetism. According to the idea given by Dr. Gilbert, there is a large permanent magnet inside the Earth. This idea is not accepted. This is because the Earth's core is mostly made up of molten nickel iron, which is at a temperature of at least 2200 degrees Celsius. Such mass is free to move by convection. It is unlikely to be permanently magnetized. The magnetic substances on Earth's crust cause the terrestrial magnetism. This idea is also rejected. This is because there is not such sufficient magnetic substances to produce the magnetic field. Dynamo theory. The Earth's magnetic field is probably caused by an electric circuit circulating in the outer molten nickel iron core of the planet. Such a process is similar to the flow of current through a coil of wire. It is the latest and the most convincing theory that explains the causes of terrestrial magnetism. Evidence of the terrestrial magnetism. A freely suspended magnet points towards the geographical north and south direction. This is because the free north pole of the magnetic needle is attracted towards the south pole of the Earth's magnet. Similarly, the free south pole of the magnetic needle is attracted towards the north pole of the terrestrial magnet. A piece of iron buried inside the earth becomes a magnet. If an iron rod is placed inside the earth in north-south direction, the magnetic properties start to develop on it. Existence of a neutral point near a bar magnet. If we draw magnetic lines of force due to bar magnet, then we find a point at which the magnetic lines of force due to bar magnet is cancelled by the Earth's magnetic field. Similarly, the angle of dip and angle of declination, there is certain value of angle of dip and angle of declination on the place at the Earth. Now let's talk about some of the important terms. Geographical axis. It is a straight line passing through the geographical poles of the Earth. It is the axis of the rotation of the Earth. Magnetic north pole. The pole of the Earth's magnet near the geographical north pole is called magnetic north pole. Magnetic south pole. The pole of the Earth's magnet near the geographical south pole is called magnetic south pole. Similarly, magnetic axis, the straight line passing through the magnetic poles of the Earth is called magnetic axis. It is inclined to the geographical axis at nearly 17 degree geographical meridian. The vertical line passing through the geographical north and south poles of the Earth is called geographical meridian. Magnetic meridian, a vertical line passing through the magnetic north and south poles of the Earth is called magnetic meridian. Geographical equator, it is an imaginary line around the Earth's surface which is at an equal distance from the geographical poles. Magnetic equator, and the locus of the point on the Earth's surface where a freely suspended magnet remains horizontal is called the magnetic equator of the Earth. Now let's talk about Earth's magnetic field. The area around the Earth where the Earth's magnetic influence can be felt is called Earth's magnetic field. Like the magnetic field of the permanent paramagnet, the Earth's magnetic field is strongest near the magnetic north and south poles and weakest near the equator. Elements of the Earth's magnetic field. To determine the magnetic field of the Earth, three quantities, namely the angle of dip, angle of declination and horizontal component of the Earth's magnetic field must be known. These three quantities are also called the elements of the Earth's magnetic field. In this video, we will discuss about only two elements. They are the angle of declination and angle of dip. Angle of declination. In 1492, Columbus observed that the compass needle does not point towards the true geographical north. And this is because of the fact that geographical poles and magnetic poles of the Earth do not coincide. The angle between the magnetic meridian and the geographical meridian at a place is called angle of declination. The declination is expressed in degree east or degree west. The angle of declination varies from place to place on the Earth's surface. It is measured by magnetic compass. Meaning of the value of an angle of declination. 5 degree east declination. The angle of declination is 5 degree east, means that the compass will point 5 degree east of the true geographical north. That means the magnetic meridian is 5 degree west of the geographical meridian. 0 in declination. It means that the north of the compass will coincide with the true geographical north. That means the magnetic meridian coincides with the geographical meridian. Uses of angle of declination. It is used in the navigation to find the true geographical direction of the place. Similarly, declination for different places is indicated in every map used by the surveyors, mariners and air pilots. Now let's talk about angle of inclination or angle of dip. In 1576, the Robert Norman, a London compass maker, suspended a compass on its center of gravity so that it could move around its vertical lines, vertical planes. So he found that it dipped north pole downwards, making an angle of 71.5 degrees. This is the angle of dip at that place. The magnetic needle suspended on its center of gravity, which is free to rotate around its vertical and horizontal planes, is called dip needle. The angle made by the axis of dip needle with the horizontal line in the magnetic meridian is called the angle of dip or angle of inclination. In Kathmandu, the angle of dip is 42 degrees. The angle of dip is measured or determined by an instrument called dip circle. In the northern hemisphere, the north pole of the magnetic needle dips below the horizontal line. Similarly, in the southern hemisphere, the south pole of the magnetic needle dips below the horizontal line. Variation of dip. The angle of dip varies from place to place. The angle of dip is 0 at the equator. Its value increases as we move toward the magnetic north and south poles. The angle of dip at the magnetic poles is 90 degrees. Angle of dip at the magnetic north pole. There is the south pole of the terrestrial magnet at the magnetic north pole. So when the dip needle is placed at the magnetic north pole, its north pole is attracted by the south pole of the terrestrial magnet. Thus, at the magnetic north pole, the angle of dip is 90 degree, north pole down, but the angle of dip is not 90 degree at geographical poles. Angle of dip at the magnetic south pole. There is the north pole of the terrestrial magnet at the magnetic south pole. At magnetic, when the needle is dip needle is kept at the magnetic south pole, its south pole is attracted by the north pole of the terrestrial magnet. Thus, at the magnetic south pole, the angle of dip is 90 degrees, south pole down. Angle of dip at magnetic equator. The magnetic equator divides the magnetic field of the Earth's magnet or terrestrial magnet into two equal halves. When the dip needle is kept at the angle magnetic equator, both poles are equally attracted by the terrestrial north magnet and the terrestrial south north pole and the south pole. In such condition, the dip needle lies parallel to the horizontal line. It means that the angle of dip at the magnetic equator is 0 degree, but the angle of dip at the geographical equator is not 0 degree. Meaning of the value of angle of dip or inclination 42 degree north at Kathmandu. It means that the north pole of a freely suspended magnet adjusts in such a way that the magnetic compass makes an angle of 42 degree with the horizontal line. That is the direction of the Earth's magnetic field dips below the horizontal line by an angle of 42 degree. Use of angle of inclination. It is used to find the direction of the Earth's magnetic field. Thank you.